systems. So, what is the geoinformatics? Geoinformatics is the integration of technology that deals with the geospatial information management and analysis, which includes the information and communications technology, that is like ICT, then global positioning system, that is GPS, and remote sensing, and GIS, along with spatial decision support system. So this is the end product, that is SDSS. Is very much helpful now in different applications like health management and natural resource management and urban planning. So each department have their own special decision support system based on their input data and their usabilities, and different processes are there. So basically, remote sensing based applications are used in the geoinformatics. So there are three basic data which are useful in the satellite as a satellite data, that is optical data. The optical, which is detect the solar radiation scattered from reflected from the different earth for me images by cameras in space, and it is the range between the visible near infrared, short wave infrared, and short wave infrareds. So it is generally the visible to infrared region in the optical region, and different colors depicts the soil, vegetations, water, constructions, along with water bodies and land use, land covers, and the different forest areas and different structure of settlements, industrial areas. So based on the optical reflectance, the different features are identified and interpreted by spectral reflectance above the signature. So this is the optical range. Then after that there is a microwave range. So in the microwave remote sensing, the sensor are emit their own microwave data, so that illuminate the target and acquire information without the help of sunlight. So it is a day night work. So these have the longer wavelength as compared to optical range, and it is a cloud free data, basically used in the flood monitoring and disaster management and earthquake management. So both day and night image are acquisitions, and atmospheric moisture contents, ozone contents. So these are the all applications in microwave range. Then the thermal infrareds. So infrared sensor that measure the thermal infrared emit from the Earth's surface, used for land surface temperatures, the surface temperature, mid wave infrared, and long wave infrareds. So these are the infrared which are range which are used for the thermal informations of the temperature of the earth surfaces or water bodies, using the different Landsat thermal bands are there. So basically in the remote sensing application, these three type of satellite sensors are very much useful for different applications based on their spectral different spectral ranges and their different spatial and radiometric resolutions. Then remote sensing and geoinformatics. So geoinformatics is based on the different driving factors, like which subject we are choosing, like for soil mapping or forest cover mapping or road network mapping or any glacial mapping. So according to this, we have to download all the satellite data. Then other informations are collected based on the ground truth. Then different softwares are used to analyze all these satellite images according to them. Then the scientific outputs are there, like for earthquake mapping, different applications are there. For land use, land cover mapping and urban plannings. So all these are urban sprawl, and then flood inundation mappings. So these are the outputs based on the driving factors, and different methods are there. Then software, different GIS softwares are now using like ISRI, that is Environmental System Research Institute. That is the full form of the ISRI, ArcGIS. So different ArcGIS versions are there, and map info, address, manifold, intergraph, geomedia, small world, grass, MS map point, ADAS imagine, Lewis, AR mapper, and JTM maps, and NV. So out of these, ISRI, RGS software, and NV software, these are the commercial softwares which are not available in the free of cost. And some of the Idris, Grass, Illuis, these are the open source softwares. So you can also download some uh, these ISRI and sorry, RGS and NV software, and some cracks are also available in the market. So these are also helpful. You can try for this. And then technology that supports GIS are remote sensing, photogrammetry, GPS, that is global positioning system, digital cartography, CAD, AutoCAD, and different softwares are there, and surveying and mappings. So based on these techniques, we use different applications and get the output. So geoinformatics deals with the different global problems, very effective manners, like terrorism, overpopulations, environmental pollutions, global recessions, deforestation, natural disaster, etc. So in the terrorism, the global positioning system is very much helpful to identify the suspects with a high accuracy, because they have the different bandwidths are there in the GPS system to locate the high accuracy positions. So in the terrorism sectors, the satellite maps and different satellite sensors are also very much useful, along with some GPS system. And then overpopulations also estimated using different spatial and non-spatial data. Then environmental pollutions are also detected using different biomass estimations, and some field-based and investigations, and some NDVI calculations and biomass estimations, along with some uh, point, sorry, salt tolerant areas. Then global recessions, also one of the factor that is also useful for this. And the deforestations are very much rely on the deforestation system, that is rely on the remote sensing based applications for the forest mapping. So if, then natural disasters like landslide, then cyclone, tsunami, and different incidents are very much easily identified using the remote sensing techniques, and different monitoring techniques are there. So this is very much helpful in the global level. Also, it is also very much helpful for local problem, for investigation in industrial facilities. So what is the nearby road or nearby scrublands of the available industrial areas, or what is the distance from the forest area, or what is the available resources. So these are the basic facilities. They are very much useful in the geoinformatics. And other local problems are also helpful. In the real world, we observe that some data is very much important. So which type of data we are using for different applications, that is very much important. So data in the means of, in the remote sensing, that is satellite data and some GIS based vector data. These are along with some non-special data. These are the useful data which is processed, then get the information. After getting the information about some, hello, then decision making is one of the factor that is getting after the information. Then various sector like natural resource management and disaster management, mitigations, health, education, business, GIS, electoral process, environmental, military applications, infrastructure, power, telecom, transport, and urban planning. These are the lot of other sectors are also there which are using the different GIS application along with other special informations. So in the natural resource management, a lot of applications are there like resource assessment, change detection, suitability analysis, scenario study, impact assessment. Suppose there is a forest area. So which type of forest plants are there? So what is the forest area, total forest area? What is the dense forest area, open forest area, scrub forest area, then other scrublands. So this is the overall idea of the classification of different forest part. So land resource management is easily available using the remote sensing technique. Then change detection, suppose for last 1 decades or 2 decades, what is the changes happened in the forest areas or in the water bodies or in the lake or lagoons, the changes of water bodies or any pollutions are there. So change detections are also useful for in the remote sensing technique and geoinformatics. Then suitability analysis like land suitability analysis for industrial mapping. So suitable sites for industrial establishment is for natural resource. Then net to road network coverage. What is the good? It is good on bad or railway networking. So nearby railway networking. Then forest areas, non-forest areas. Then and different settlements areas. Then water availability like nearby rivers are there. So these are the nearby resources that these are the very much useful for suitability analysis. So industrial analysis are very much mm, most of the time used for the remote sensing technique. Then business analysis, then other factors are there. Then scenario studies, so overall particular landscape have how much different land use and land covers are there, so that that type of changes are analyzed using scenario study. Then impact assessment, so suppose there is a mining area or any industrial area, how this mining or industrial area impact the surrounding 10 kilometer or 15-kilometer buffer areas by calculating this water different parameter of the water bodies, groundwater or in drinking waters. Then different so waste management techniques. Then the green cover of the nearby forest, that is NDVI calculations. Then these are the factors which are analyzed using remote sensing technique and geoinformatics. So impact assessment now very much useful for the permission for the establishment of some plants in the forest department. There is every state has some state environmental impact assessment authority is there. So this authority will decide how this industry impact in the local bodies. So if it is uh, very much harmful for the industry, then it is the action is taken by this authority. So a lot of industrial corridors or industrial establishment are a lot of industry are established based on this environmental impact assessment survey. So these are very much nowadays useful in different departments. Then natural resource management applications like water resource assessment, land use planning, soil erosion potential evaluations, watershed planning, vegetation mapping, then ecosystem analysis, conservation planning, risk assessment, coastal zone management, and hazard mapping. For the different water resource assessment like dam constructions and water availability, what is the geological structure of this land part, that is lineaments are there or dikes are there or not, then what is the soil type, so water holding capability is there or not, which type of soil is there. So these are the factors which are give the more information about the land, then the water resource managements are there. So based on this data, the water resource management are taking care. So land use planning for different purposes are used for land use planning. So common is nowadays is land use planning for urban mapping. That is also land use planning is required for other uh, forest analysis, also land use land cover mapping also taken care. So for different department needs their land use land cover planning. So this is the basic needs for different applications or different monitoring systems. Then watershed plannings, then vegetation mapping. So what is in the watershed planning? Suppose LBCT, the lower Buller check dams near the hill areas or other uh, check dams are there. So how to choose a suitable site for the check dam. So the elevations factor is one of the factor. Then the agricultural land. Then what is the groundwater conditions are there. So these are the factor for the watershed planning. Then vegetation mappings for different crops are growing in different district or different landscapes. So what is the diversity of the vegetations and what is the different crops are growing. So what is the factor that these crops are growing in different areas based on the soil and based on the availability of the water and groundwater position, and some of the coastal areas there is 2 to 3 times crops are paddy crops are grown, but in the hilly terrain that is not possible because of the availability of the water. So the variety of vegetations are also uh, seen in different landscapes. So these are these informations are very much useful for monitoring the total landscape along with planning and precision farming. So this is the one of the factor in the agriculture applications. Then ecosystem analysis. Suppose there is a coastal areas, there is a mud flood area, then mangrove area, then um, aquaculture areas. So how this ecosystem affect the different wild animals like a crocodile or other different migratory birds, along with different turtle which are nesting in near the beach of the coastal area. So the ecosystem analysis also very much helpful for the conserving the wildlife animals. Then conservation plannings, then also risk assessment. So what is the risk for the uh, construction of some of the structures. Then coastal zone management. So the coastal areas, a lot of shoreline change and a lot of the land degradations are happen because this is a dynamic landscape. So gradually the changes in the shoreline or near the coast is very much frequent. And there is sometimes it is eroded in the coastal area and next year it is deposited. So coastal management and hazard mapping is very much important as it is a very low zone areas. So slope mapping is very much important because in low slope area there is a risk for the flooding and the risk for the high cyclone affected area. So for the construction of cyclone shelter buildings, then construction of different sea wall, then groins which are protecting the river from the erosion. So these type of coastal structures are prepared based on the coastal management plan and the landscape analysis. In the disaster management and mitigation, these are the factor that is earthquake, drought, fire, flood, cyclone, landslide, erosion, volcano. So for the landslide, flood, and earthquake, the remote sensing satellites like microwave remote sensing satellites are very much useful for the monitoring and analysis for the flood and earthquake and specifically landslides. But for cyclones and forest fire, that is the other uh, satellite images are helpful based on the field survey data. And this is the map of the flood vulnerable zone of Ahmedabad city. So, based on the availability of the data and the satellite image, uh, different. So, when we choosing the flood vulnerability zone, so we use generally slope map along with the drainage pattern of this city along with the flood inundation zone. Suppose for 2021, the flood, the water inundation zone is uh, some uh, some square kilometers. So these are mapped based on the satellite image, microwave satellite image. Then for 2022-23, how the water in the flood zone is spread or most of the frequency, high frequency flood events are there. So these are mapped. Then after that, the zoning is prepared. So in the red zone, the maximum flood events are there. So that's why it is marked as the very high vulnerable zone. And it's also a very low elevation areas. So it is easily affected by the uh, flood. And so the green areas are very low populated areas and some high elevated areas. So it is a low probability of the flood risk. That's why it is regarded as very low vulnerable zone. So that's why it is divided into 5 zones. So high, very low to very high vulnerable zone. So based on this vulnerable zone, the different planning, different constructions of different uh, landscapes are there. So it is protected by using different infrastructure planning to reduce the risk of the vulnerability zone. So based on this satellite image and all these other um, field survey data, so this type of maps are prepared. Though based on this map, the urban and the city planning are going to plan for the protection of this flood vulnerabilities. So this is the elevation map. So how the flood inundations are there in the monsoon season or any rainy seasons. There is a 3D model based on the satellite image and other elevation data. Then this is one of the satellite image which is before the tsunami, then after the tsunami. So how this affect the overall areas. So it is the Machilipatnam area in the Andhra Pradesh. how the tsunami affected. So pre-event areas, which is shown in the yellow round, then post-event, that is highly inundated areas with water entered into all the land parts. So this is the event. Then in the Chennai city, near the Adyar River, river mouth, it is the pre-event. So this the river mouth is generally closed by the sandbars before the events. So after the tsunami, the bar is open, and this totally the high inundated area is the water bodies enter into all the parts. So this is the post event. So this type of monitoring are going on for different cities in the flood events and cyclone events and tsunami. So tsunami is not happening frequently, but most of the cyclone in the coastal zone of the east coast and flood events, most of the in the cities are monitoring using different satellite images. So this is also one of the part of the Marina Beach before event and then the past events. So landslides and earthquakes, major level of landslides and earthquakes are present in the Himalaya regions, 1, 2, and 3 region. That is the western region, then eastern Himalayas, and in the western Ghats, and near the mm, Kerala and Mangalore. So the Western Ghats areas are highly vulnerable for the landslides. So it is most of the years, most of the landslides are happening in the this region, and also in the Himalaya regions. So managing disasters, why geoinformatics is used. So for the better decision and informed actions, action decision model. So different models are used for the analyzing different tsunami events and other landslides areas. Then measurements, historical largely applied, then individual systems. So the, it is benefited by the understanding, then efficiency, then cost saving, then improved analysis, then effective planning, better decision making, and then a better communication, collaboration, and coordination based on the different highly accuracy techniques. So geoinformatics generally provides data analysis on the disasters phenomena, that is landslide, flood, earthquake, and their location, frequency, magnitude, risk, potential assessment and monitoring, post-disaster damage assessment, and data on the element that will be destroyed if the event is take place. So data analysis and prediction on the disaster. Then common objectives is the protection of life and properties and provide a critical timely informations, provide the appropriate and timely response, provide for basic life support needs, provide for the expeditious recovery, seek improvement, expand capacity. So it is very much uh, quick quick action works are going on based on this application. So not only in the civilian use, but in the military and defense application, also use different remote sensing techniques like different satellite image and this is political image. There is international boundaries and some command areas and different border areas. So for the monitoring and different applications, so military use also different maps and survey data along with some satellite data. Forest areas, a lot of the state forest has have some forest management information system. So they have some all the GIS based data, remote sensing based data, and the survey based data. So based on their application, they use different data for different applications. So forest resource mapping or monitoring use different satellite images and the encroachment investigations, forest fire assessments. So thermal bands of the satellite image are very much helpful for forest fire estimations. How much area is uh, covered with the forest fires? So what is the source of the forest fire? So this is one of the map which is seen in the 1972 to 75. Then forest cover in 1982-82 and 1982-82. So how this forest changes? So most of the forests are degraded between these 10 years. So this type of classifications are there, like closed forest, that is dense forest, mangrove forest, open degraded forest, non-forest, and other forest are classified. So this is one of the forest area that is based on the NDVI, that is normal and defensive vegetation index. So greater than 5, there is a zero point 0.6, there is a greater than zero point 0.6, which indicates the high density of the forest areas. So between 0 to zero point 0.2, there is a very unhealthy vegetations and degraded forest are there. So this is the forest area classification based on NDVA calculations in 2014 and it is 2022. So it changes with a lot of areas. It changes. So every 2 year there is a Indian state of forest report is prepared based on the different remote sensing and other data. So what is the forest status of the India? So each states have some with state-wise informations are there, state-wise maps, statistics are there. So what is the changes in the forest areas in the last 2 years, district-wise, state-wise, and all over the India. So these are prepared by the Forest Survey of India. So the gain and losses in the forest cover since 2019. This is the map. So this negative changes. So a lot of the forest cover degraded in the northeast region, West Bengal, and in the western region. Some of the forest gain in Odisha and Andhra Pradesh areas and in the Kerala areas. So this is the status they give in the 19. What is the forest cover in 2019? What is the forest cover in 2021? So these are the changes. Tree cover, forest cover, and according to them, the Andhra Pradesh has the highest changes in the positive ways, and Arunachal Pradesh is the very uh, negative ways, the loss in the square kilometer of forests due to the different factors are there. So Andhra Pradesh, Telangana, Odisha, Karnataka, Jharkhand, these are the gain of the forest areas as per the forest report. And also some of the urban areas forest cover is also calculated. So in the Delhi, that is a positive changes in the 11%, then Mumbai plus 9%, in Bangalore that is a minus 5%, Hyderabad that is a positive, and Ahmedabad that is a negative ways. That is a development of the city. That's why the degraded of the forest cover is happening, and in increase also in the Kolkata region. Then after that, that the agriculture in the lot of applications are there, and nowadays remote sensing technology is very much useful in the agriculture development. There is crop water requirement prediction, crop acreage yield estimations, crop condition assessment. There is SRI, systematic rice research, rice and intensifications are there. Crop condition assessment, soil moisture evaluations, suitability mapping. So crop damage and crop health assessment are also useful for the micro remote sensing. Then the business factors in the business sector also geoinformatics and GIS is very much helpful, like supply chain management, marketing, site selections, consumer management, logistics, intelligence, routing, demographic analysis. Precisely, GIS can be useful for this. Detection of potential market, data detection of dealer. A lot of things are there. And for urban planning, how the urban sprawl is going on, what is the status of the particular urban area. So the lot of previous year data for the 20 to 30 years are gathered using different survey data and satellite image. So after that, the cadastral based mapping and land management are prepared using land to land cover mapping. Then site, which sites, some site selections are also there. So this is the one of the example. There is a Pune city, which is shown in the left side. There is Survey of India topography in the 1:25,000 scale, and the right side image, that is a satellite image, that is a list 3 satellite image, that is which has the spatial resolution of 23.5 meter. So there are four zones are um, divided into zone 1, zone 2, zone 3, and the 1979 to 1980 there is the map of the urban areas. So it is in the 2008 the urban sprawl is drastically changes. So the growth of the urban area is in the northeast direction, that is zone 3. So this and what is the factor for the urban sprawl is also detected using different survey data. So that type of planning and mappings are going on. So the zone which are very fastly growing, so they are given the priority for the protection of different uh, uh, factors are there, like different structures are prepared for the protection of different flood managements. So the growth direction are given in this chart. So which area the growth is more and which areas is growth is less. Based on the economy and the different factors, the growth will increases in different directions. In zone-wise urban sprawl of Pune city of 2008. So this right center is a high growth, and there's a left side there is a low growth. So this type of mappings are now and is most of the time it is useful, and it takes more time because it is a very high resolution satellite image is needed. Then cadastral based analysis are there. So survey data is very much useful, and lot of survey data are gathered and then incorporated in this analysis. After that, all information are gathered, then give you a good result. And this type of analysis takes minimum 6 to 7 months. Then different village level informations of a particular districts are also analyzed. So this is some satellite data of a particular area. So it is a high resolution satellite data. It is a Google Earth data. So it is georeference. Then after that, it is uh, interpreted using different techniques. So this data, this is a land use land cover map of a particular village. So it is a large scale map, tree covers, road, bridge, house. So the type of land use land cover of a particular small areas are also calculated for different purposes. So in the agricultural line, that is a crop system analysis, soil mapping monitoring, agriculture land monitoring, soil moisture status monitoring, land in and cover monitoring are going on. Then forest, the forest health, agroforestry mapping, forest cover mapping, deforestation, species inventories, then forest fire detections. All these are uh, calculated by using the remote sensing and geoinformatics. Then application of remote sensing water resource managements, glacial dynamic, wetland mapping, then river and lake ice monitoring, irrigations and soil moisture estimations. So a lot of departments like water resource, urban planning, forest department, then other agriculture department, then other different all a lot of departments are there which are relying on this geoinformatics technique. Then in the GIS techniques which are useful for the disaster management, that is flood, earthquake, cyclone, landslide, avalanches, biological disaster, accidental disasters. All these disasters are monitoring using different satellite data, drone, GPS, internet, then aerial photograph, field attribute data, means field survey data, and some topographic land use land cover data, geology, elevations, infrastructure, structure risk. All these are integrated. Then after that, all these events are monitoring and give the result like estimation damage infrastructure, storm risk vulnerability zone mapping, forecast of the disaster, alternate route solutions, population and properties at risk, response recovery. All these result-based or result-oriented informations are calculated based on the different satellite images, aerial photograph, and other land cover mapping. So it is very nowadays most of the remote sensing satellites are useful in the disaster mapping. Then there is a special decision support system. So in the all department like disaster management, health sector, urban sector, water resource, so they have they all the different special decision support system. So in this slide, there is a special decision support system for malaria control and prevention. So in this, there is the input of some GIS software, then hardware that is computer and GPS data, then household data, ground data, total population, entomological data, then geospatial data like climate factor, environmental factors, and temperature. These type of data are prepared using different remote sensing satellite image and other climatic data. Then route survey, malaria cases. These are all field survey data. All are integrated in the SDSS for dengue, chikungunya, and malaria. So after that, the coverage of information distribution of positive cases, tabular reports, statistical analysis, then planning, coordination, different applications are there, field level. So suppose there is a malaria prone area, then dengue area. What is the statistics of that particular village, or it is a uh, water inundated areas, or it is a very scrubland or in the forest area, and it is how the land is land cover, how the status of the people of this village, and so a lot of surveys are random surveys are there. Then after getting all this data, then there is a planning and coordination level. They decide what is the root cause of this disease and what is the monitoring applications. Then what is the impact on the large level. So this type of support decision system, special decision support system, that is uh, for different department and currently going on for effective planning and management. Okay, and these are the slides.